Hi guys, today is May 21st and we're going to do polar functions for day one. And we're going to talk about different coordinate systems, okay? So this is the first time you've ever seen anything like this, okay? But there's different coordinate systems. You're used to one type and it's called rectangular coordinates. Some people call this Cartesian coordinates from Rene Descartes, who was a philosopher and mathematician, okay? But what it does is basically you move left or right, and that's what the X tells you, right? Okay, and this is nothing new to you. Okay, so left or right, and then the second coordinate, the Y, tells you up or down in this plane. Okay, so like the point 2, 3, you would start right here at the origin, right? And you'd go right 2, and then you'd go up 3. So you'd mark the point right here, and that's the location of a point, right? And that would have coordinates 2 comma 3. Okay, and then and you can do this even in 3 dimensions. Okay, so you could go left, right, up, down. Well, actually this would be front and back, and then you go up and down out of the paper. Okay, so that happens later on. It's multivariable calculus. Okay, and you get some really cool 3-dimensional graphs and stuff. Okay, all right, so here's the new system that we can locate points in this plane, like on a piece of paper, okay? And the way we do it is we give a coordinate, and the first coordinate is we call r, and that's the radius, okay? And that's the distance from the origin, okay? So this is the distance from the origin. Okay, and then this theta is the angle of rotation. So we go out a radius, and we rotate, and then that'd be like the terminal side, and then we rotate that angle, okay, whatever this angle is right here. So this is the angle of rotation. Okay, so you have these like circular grids because these represent all the different radiuses you could have, okay, all the circles, okay? All of the circles have a center at 0, 0. That's the origin. It's also called a pole, okay? And that's why this is called polar coordinates, all right? And then these are different angles. So if you look from here, this is angle 0, okay? And I've overlaid an XY axis on top of this, okay? But this would be angle 0. This would be angle pi, or 180 degrees, depending if you're in angle in radians or degrees. Okay, and if you count these radii that are coming out, so 1, 2, 3, 4, 5, 6, because this is one of them right here, 7, 8, 9, 10, 11, 12. From 0 to pi is broken into 12 equal pieces, right? So each one would have to be pi over 12. Okay, so this would be pi over 12. This would be 2 pi over 12, but that can be reduced. This is really pi over 6. And then this would be 3 pi over 12. And then this would be 4 pi over 12, which is really pi over 3. And then this would be 5 pi over 12. And then this would be 6 pi over 12, which is really pi over 2. 7 pi over 12. Okay, let's just go ahead and do it. 7 pi over 12. Okay, this would be 8 pi over 12, but 8 pi over 12 reduces to 2 pi over 3. This would be 9. That was 8 pi over 12, so this is going to be 9 pi over 12. And 9 pi over 12 is 3 pi over 4. Hold on. Yeah, 3 pi over 4. You know what? I just made a mistake. I just realized. Sorry, guys. 3 pi over 12, what is that? That's pi over 4. Holy cow. All right, sorry. Because that would reduce to pi over 4. Okay, so this one, all of a sudden I was like, wait, why am I getting pi over 4? That makes sense. Okay, sorry. This is 3 pi over 4. I feel really stupid right now, okay? And then this would be, because that was 8, this is 9, this is 10, 10 pi over 12, and 10 pi over 12 is 5 pi over 6. And then this would be 11 pi over 12. Okay? All right, so here we go. Let's do one of these, okay? And I'll talk about just something in just a minute. Okay, so let's say we want to find the point 2 comma 5 pi over 6. Okay, so it really doesn't matter which one you do first. Okay, whether you do the angle or you do the radius. Okay, if you do the radius, you would start here at the origin, you'd go out 2, and then you'd rotate around the circle with radius 2 until you get to an angle of 5 pi over 6, which would be right here. Okay, some people, so that's one way, radius and then rotate around. Okay, or some people, okay, some people decide to do the angle first, so they just go, okay, here's 5 pi over 6, and I'm going to go how many radiuses in that direction. Okay, all right, so I want to say so this point right here would be 2 comma 5 pi over 6. Okay, so now I'm going to do another one. Okay, so what would this point be? Right here. Okay, that point right there, okay, would be 2 comma negative pi over 6. Okay, so this point would be 2 comma, where we rotate negative pi over 6. You could also rotate with a positive angle. Okay, and if you rotated with a positive angle, that'd be 11 pi over 6. So we could also do the same point. We could do 2 comma 11 pi over 6. Okay, because if we count by pi over 12s, this is 12 pi over 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22 pi over 12s, right? Which is 11 pi over 6 if you reduce it, okay? All right, now, here's what's weird, okay? You can have a negative radius on these, okay? And it's like vectors, all right? It's in the opposite direction of the angle, okay? So right here, this is 2 comma 5 pi over 6. This point right here could also be negative 2 comma, all right, negative pi over 6. Okay, so you could rotate down to negative pi over 6, but you wouldn't go in this direction. You'd go opposite that angle. So you'd go in this direction, and that's, this negative tells you you're going to go the opposite, the directly opposite of the angle of rotation. It's kind of crazy. Okay, I don't like using that much, but it does come up in formulas, okay, when we start relating the radius and the angle, and you get some really funky graphs on these, okay? All right. So this one, and so this one could also, this all describes this, these two coordinates describe this point right here, okay? So radius 2, rotate 5 pi over 6. Rotate, this one you'd have to rotate first. So we would rotate down negative pi over 6, but instead of going towards the negative pi over 6 angle, we're going to go directly opposite, which would be this way. Okay, so if you look, these two line up. Okay, they're on the same line. Let me grab a ruler to show you. So these line up, right? Because they're directly opposite one another. Okay. You could also do this. This could also be negative 2 comma 11 pi over 6. That would still describe this one. Okay. This one is this point right here, right? And so this one could be written as negative 2 comma 5 pi over 6. Okay, so we'd rotate 5 pi over 6, right, to here, and instead of going towards the 5 pi over 6 angle, we're going to go directly opposite, right, because of the negative 2. okay? Sometimes that's hard for people because you got to do the angle first and then go, okay, we got to go in the opposite direction of that angle, okay? All right, that's probably one of the hardest things we're going to do today, okay, is the negative radiuses, okay? All right, so let's go and let's do the relationships, which is at the bottom of this page. Okay, so some of the relationships we have to know and understand all come from this diagram, okay? So this point right here has an X and a Y coordinate, right? But it also now, from what we just learned, has another way of describing where the location of this point, and it would be r comma theta. So there's two ways to describe the location of this point, okay? Now, how are these all related to each other? Okay, so this is my y, right? And this would be my x, okay? And this is my r, and my theta would be this right here, okay? That's my angle theta, okay? And this is my reference angle alpha, okay? And so we can relate x, y, and r by the Pythagorean theorem. That's one thing, okay? So x squared plus y squared is equal to r squared, or r would be equal to the square root of x squared plus y squared. All right. Cosine of angle theta, and this will always work, cosine of angle theta is equal to this x over the r. Okay, which means x would have to equal r times cosine of angle theta. So if we have, basically this is it. This is a way to take our points in polar form, right, where we have the radius and the angle theta, and we can get the x coordinate in Cartesian or rectangular coordinates. Okay, we can do the same thing with y. Okay, so because we know that sine of theta is equal to y over r. So that would mean that y must equal r sine of angle theta, okay? And then the other one is this, okay? So tan of angle theta is equal to y over x, okay? Now, we can get angle theta, okay? And we got to be careful on this. So I'm going to just, there's some disclaimers on this, okay? So theta is equal to tan inverse of y over x. And this isn't necessarily always true. Okay, why? Because the domain and range restrictions on tan inverse, okay, remember, this angle can only be a positive angle or a negative angle, right? Okay, so what happens here is we got to pay attention to the location of this. What quadrant is our point in? So we have to make some adjustments to this, okay? All right, and I'll talk about that more in a minute, okay? Now, if we do tan inverse, okay, and both of these are positive, right? Then we could be here, but we could also be over here, right? So here's the problem. We have to know, and if it's down here, okay, if we know the point is in the third quadrant, to get our theta, we know we're going to have to take the 180 degrees or pi and add it to this, okay? All right. And there's no way we're ever going to get out of this an angle between pi over 2 and pi. We're going to get an angle between negative pi over 2 and 0, okay? Because of the restrictions on what tan inverse does, okay? So we got to watch out, okay? We got to watch out. Okay? Using tan inverse, okay, theta is less than pi over 2 and bigger than negative pi over 2. So it's somewhere over in here, right? So we can never get this angle and we can never get this angle, but yet you can have that angle. We just can't get it out of using tan inverse. So we have to work kind of smart and understand, okay? So maybe that's another difficult thing, okay? But I'm going to show you some examples where that happens, okay? And we'll talk about it, all right? Okay, so we know that r is equal to the square root of x squared plus y squared, or r squared is equal to x squared plus y squared. we know x is equal to r cosine theta. And hey, this is a lot like vectors, right? And y is equal to r sine theta, and theta is equal to tan inverse of y over x, okay? Whew, okay, let's do some problems. So for this first set of examples, okay, these A and B, what we're gonna do is we're gonna plot each point and then find the rectangular coordinates for the points with the given polar coordinates, okay? So right here, okay, I'm gonna rotate angle pi over 2. So this is 0 and this would be pi over 2, right, on the positive y-axis. And we're gonna do a radius of 4. So we're just gonna go straight out, boom, right there. Okay, so I'm actually kind of starting with one that you should already realize what the Cartesian ones are, right? Or the rectangular coordinates are, because this would be 0, 4, right? Yep. Okay, so this is 4 comma pi over 2. All right, and so we can get the rectangular coordinates, okay, by taking x, and it's always going to equal our radius, which is in this case is 4, okay, and then cosine of pi over 2. Well, cosine of pi over 2 is 0, right? So this would be x is equal to 0. And our y would be equal to 4 sine of pi over 2. And sine of pi over 2 is 1. So this would be 4 times 1. So our y is 1. Okay, oops, not 1. 4, because 4 times 1. Okay, so this would be the same as, here I am, I'm going to write 4 comma 0. It's not 4 comma 0, right? Because our x is 0. 0 comma 4. Okay, so 4 comma pi over 2 in polar coordinates is 0 comma 4 in rectangular coordinates. Okay, all right, let's go to the okay part. So notice something, we have a negative radius here, right? Okay, so if we rotate angle pi, right, we rotate to here, but we're not going to plot our point going in the angle pi direction, right? We're going to go opposite it. So we're going to go over this way, right there. Okay, and this point right here is -3 comma pi. Well, we also know it in rectangular coordinates as 3 comma 0, right? So when we do this, we should get 3 comma 0. So x is equal to -3 cosine of pi, and y would equal -3 sine of pi, okay? So cosine of pi is -1, right? And -3 times -1 is +3. So x is equal to 3. Sine of pi is 0. 0 times -3, y would be 0. So this point is also 3 comma 0, just like we thought, right? Okay, so I did some ones that like we can just see it and realize, oh, it works, right? Okay, so that's why I want to start with this. Let's go to the next one, and we're going to do some that we may not know right off the top of our head, okay? So this one is 4 comma 5 pi over 6, right? So we rotate 5 pi over 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this each radius would be an angle of pi over 12. So this is right here would be 5 pi over 6. Okay, so we're going to rotate to that angle 5 pi over 6, and we're going to go out a radius of 4. That would put me right here. Okay, so this point right here is the point 4 comma 5 pi over 6, right? Well, what's the x and the y? So here's where, like, it's really nice points, right, in polar, but it's not going to be that necessarily nice in rectangular, okay? So I know from this that x has to equal 4 cosine of 5 pi over 6. And y has to equal 4 sine of 5 pi over 6. Okay, so now one thing we should know, okay, by the location of it, right? Our x has to come out to be negative, right? Because to get here, we'd have to go left and then up. So this one's going to be positive, and this one's going to be, this one's going to be negative, and this one's going to be positive, okay? So this would be x is equal to 4, and then cosine of 5 pi over 6 would be the square root of 3 over 2, all right? And then 2 goes into 4 twice, so that means x is 2 square roots of 3, okay? Sine of 5 pi over 6 is 1/2. So this would mean y is equal to 4 times 1/2. And 4 times 1/2 is 2. So this would be y is equal to 2. And it kind of lines up, right? It kind of makes sense, okay? So the same point in rectangular would be 2 square roots of 3 comma 2, okay? All right, so polar, rectangular, okay? All right, let's do the next one. All right, guys, so to do this one, okay, we have negative square root of 2 comma negative pi over 4. To know, we need to know what the square root of 2 is to kind of graph this, all right? So this would be equivalent to like roughly negative 1.4 comma negative pi over 4. Okay, so we have a negative radius, right? So we're going to need to go in the opposite direction of negative pi over 4, okay? So negative pi over 4 would be rotating clockwise, and this would be negative pi over 4 right in the middle here, right? So directly opposite of that would be 3 pi over 4, right? So right here, okay? And we're gonna go 1.4. Now, pay attention to this, okay? Because I'm gonna tell you something. I'm redoing this because I made a mistake, all right? Because I counted each one of these by 1, but it's not, right? This is 0.5 radius, this is 1 radius, this is 1.5 radius, and this is 2. So 1.4, okay, along this angle line, right, would be, this would be 0.1, this would be 1, and then 1.4, right, would be right about here. But we're not supposed to go in the direction of negative pi over 4. We need to go in the opposite direction, right? So we're going to go this way, right? So this would be 0.5, this would be 1, and then 1.4 would be right about here. Sometimes I'm going to tell you this, and sometimes it's helpful to use a ruler to make sure you're on the same line, because you could be off just a little bit and not realize it, okay? So right here, these are on the same line, right? So this would be angle pi over 4, so you can count easier, okay? So this would be 0.5, 1, 1.5, so 1.4 would be right about here, okay? So right about here, okay, is the point, okay? That point is negative square root of 2 comma negative pi over 4. And that'd be the location of the point for those with those coordinates, okay? Now, what is that in rectangular coordinates or Cartesian coordinates, right? So x would equal my r, which is negative square root of 2, cosine of negative pi over 4, and my y would be also negative square root of 2 sine of negative pi over 4. Okay, so we got to figure out negative pi over 4, right? So you could draw a quick little diagram, right? Negative pi over 4 would put you in the 4th quadrant. My reference angle would be pi over 4. So this would be negative 1 because my y, and my x would be 1, and this would be square root of 2. So my x is equal to negative square root of 2 cosine of negative pi over 4, which would be positive 1 over the square root of 2. And my square root of 2's would cancel, and I'd be left with x is equal to negative 1. And y is equal to negative square root of 2 sine of negative pi over 4, and that would be negative 1 over the square root of 2, okay? And so negative times negative is going to be a positive, and so this would be y is equal to positive 1, right? And so our rectangular coordinates for this would be negative 1 comma 1. And if you look at this, that kind of makes sense, right? Okay, because this point puts us into the second quadrant, right? And in the second quadrant, x is negative and y is positive, right? Okay, so that's how you would go from rectangular, okay, polar coordinates to rectangular coordinates, okay? All right, so let's do the next thing I want to say is rectangular coordinates are unique, okay, in the sense that there's only one way to write it, and that's it. Like there's not another way to write that same point, okay? In polar, there are multiple ways of writing the same point, okay? So right here, we're gonna go, now what we're gonna do is we're gonna go from rectangular and then write it in polar, okay? All right, so we wanna plot each point and find two different sets of polar coordinates for the same points with the given rectangular coordinates, okay? All right, so some of these we can do in our head, okay? So like this one, we want to go right 1 and up 0. So that would be this point right here. Okay. All right. So what we could do to get this is we could do formal, right? Actually, let's do it informally. Okay. So like looking at this, right? What's one way we could do this? Well, we could do a radius of 1, and what angle would we go? We'd go 0, right? So this would be, we could write this as 1 comma 0. Okay. And this right here, that would be my radius, right? That'd be my R, and my angle would be 0 theta, right? Now, it looks like the same, right? So if you don't tell somebody that this is polar coordinates, they would think this is the X and the Y, right? But it's not. It's the R and the theta. It just happens to be the same thing here, right? Okay. Now, what's another way? What if we did an angle of pi? And you could do that because that's over here, right? We would have to go, instead of going in this direction of angle pi, we'd have to go in the opposite direction, right? So our R would have to be -1. So that's another way of doing it, okay? We could also go with negative pi, okay? But we would still need a radius of -1. So we could do -1 comma negative pi. So I'm going to do more than 2 here, okay? We could also go 1 comma 2 pi. Okay, so we could start here, go all the way around once, and then go out a radius of 1. Okay, so that'd be this one. Or we could do -1. So we're negative radius. So we're going to have an angle that's over here, right? So it could be pi, it could be negative pi. It could also be 3 pi. Okay, so these are all different. You can just look at it and go, oh, the angle is this, right? And you can just write it. And I'm fine with that, okay? All right. Okay, so now we're going to get into the next part, okay? All right, so here we go. Okay. I wish I'd paused that. Okay, so how about something like this? The point -2, 2. Okay, so we're going to go left 2 and up 2. Okay. All right, so I'm going to go ahead and draw my radius in because I want to show you everything. Okay, now this is going to be, this right here is my Y, and this is my X, right? So in this case, this would be 2, and this one would be -2, right? And I know that this is going to be my angle theta. Now, here's a problem. I'm not going to be able to use tan inverse on this, okay? Why? Because I'm not going to be able to get an angle into this second quadrant, because there's no way to use tan inverse and get an angle between pi and pi over 2, or pi over 2 and pi, okay? No way to do it. Tan inverse doesn't do that, okay? It's outside the range of it, okay? Okay, so how else are we going to do it? Well, we can get the radius, right? Okay, so the radius, we know that x squared plus y squared equals r squared. So right here's my radius, right? So I could do -2 squared plus 2 squared must equal r squared, right? So this would be 4 plus 4, right, which is 8. So I know r squared must equal 8, which means r would have to be plus or minus the square root of 8, right? So r is equal to plus or minus 2 square roots of 2, okay? So we know our radius, right? And I'm going to do the positive one. It's just easier, I think, if we do that, okay? So what's this angle of rotation, okay? So I'm going to wind up getting my alpha right here. I'm going to do it in red. All right. We can use tan inverse to get our alpha, okay? And so alpha must equal tan inverse of, okay, so this is an acute angle, and we can get acute angles using tan inverse, okay? But we want all our coordinates to be positive, okay? So we're looking at this like you did in math 2, okay? Where you had positive links for rectangles, or not triangles, okay? So ry is 2, and we got to think of this as being a length, okay, instead of a direction, okay? So 2 over 2, okay, which would be tan inverse of 1, right? And tan inverse of 1 is equal to pi over 4, okay? So that's in radians, right? We could also do 45 degrees if we were doing degrees, okay? Now, that's not theta, right? Okay, so what's theta? Well, I gotta back off from here, which is 180 degrees or pi, and I gotta back off my alpha to get my theta, okay? So when you do this, okay, if you're not in the first quadrant, okay, you're going to get your alpha by doing tan inverse, okay? And then to get your angle theta, you're going to manipulate it like either add or subtract pi or 2 pi, okay? So our angle theta would equal pi minus pi over 4. Now this would be 4 pi over 4, right? Minus pi over 4. And that would be 3 pi over 4, right? And some of you go, oh, wait, that's just, if that's pi over 4, then the rotation has to be 3 pi over 4. That's fine, okay? You don't have to go through all this, okay? I'm just showing you the detail of like why, okay? All right, so we've got it, right? We've got our R and we've got our angle of rotation. So if we want to do this angle of rotation, 3 pi over 4, we would have to have the positive radius, right? So one version of this would be, okay, 2 square roots of 2, comma, 3 pi over 4. And that's the simplest one, right? We go out a radius and we rotate, okay? Now, I asked you for find 2 different sets of polar coordinates, right? Okay, so if you could just add a full rotation to this and you'd have another one, right? So you could do 2 square roots of 2 and take the 3 pi over 4 and do a full rotation, right? So 2 pi, and then you'd have another point that's at the same exact location, right? Because you're just going around more than once, okay? So this would be 8 pi over 4 plus the 3 pi over 4 would give you 11 pi over 4. So another option would be 2 square roots of 2, comma, and 11 pi over 4. This is just to show you how I'm getting this, okay? I just didn't want to do it, okay? Okay, how about if we do a negative radius, right? What if we do a negative radius, right? Okay, so that would mean I'd have to rotate down this way, right? And you could do vertical angles here. And so this angle would be negative pi over 4. And so we could do a negative, we could use this, right, to get the negative angle and then just go in the opposite direction, okay? So we could write this as negative 2 square roots of 2, comma, all right? Now, that would mean I need this angle down here, right? And this angle down here would be negative pi over 4. Okay? So that's how you would do it, okay? All right? You could, okay, so let me say this. You could make this be your theta, but then you'd have to make this 2 and negative 2, and then you'd have to take in consideration, with tan inverse, you're gonna get an angle either here or an angle here, right? And if you want your point to be over here, if you get this angle, you're gonna have to make your radius be negative. Okay, so that's one way to do it. If you had done tan inverse of 2 over negative 2, right? Okay, then you would have gotten negative pi over 4, which would have been this one, right? And if you kept it as a positive radius, then that means our point's down here, but it's not. It's in the opposite direction, right? So just some things to think about, okay? I should have said this, okay? Let me point to this. Right here, we want to use, if you want to get the reference angle, you need to use positive side lengths. Because then you're treating this triangle as a triangle from like Math 2, okay? Hopefully I didn't over explain that to you guys, okay? All right, so let's go to the next one, all right? And we'll do that one. Okay, so for this next one, okay, we are at negative 2 square roots of 3, comma, negative 2. All right, so that's gonna be, okay, that's a roughly negative 3.5, comma, negative 2. We can really only graph to the 10th place. I mean, kind of accurately, okay? All right, so we're going to go left and down, right? So negative 3.5 roughly here, and then negative 2 right here. Okay, so that's the point right here. That's the point. Negative 2 square roots of 3, comma, negative 2. Okay, and so we need to figure out our y. Well, we need to figure out our r, right? We know what our y is. So this would be our x, this would be our y. We're going to need to figure out our r. We're going to need to also figure out this angle theta, right? But to get this angle theta, we're going to find this angle alpha. This is how I do it, okay? There are other ways. I want to say that really clearly. There's other ways to do this, okay? There's no way to use tan inverse to get this one, okay? There's no way, all right? If you use directly the side, like negative 2 and negative 2 square roots of 3, okay? Because you're going to get an angle up here, right? Okay, so I want to find alpha, which means I'm going to use the positive sides, okay? Okay, so here we go. How do I find my radius? Well, I know that x, which is negative 2 square roots of 3 squared plus negative 2 squared has to equal r squared, okay? So this would be 4 times, this becomes 4, this is 3, so 4 times 3 is 12, right? 12 plus, and this would be 4, is equal to r squared, right? And so that would mean r squared is equal to 16, which means r could be plus or minus 4, okay? Now, we're going to get our alpha, right? And our alpha is tan inverse of y, okay, which is, I'm going to make, and this is, again, I'm going to make them be positive, right? Because if we make them positive, you're going to get a reference angle that's between 0 and pi over 2, okay? So my y is going to be 2, okay? And so that's the opposite side is 2, and the adjacent side is 2 square roots of 3. Okay, so that would be tan inverse of 1 over the square root of 3, okay? So my y, my vertical leg would be 1, right? And my horizontal leg would have to be square root of 3. That only happens at an angle of pi over 6. So this is pi over 6. Now that means this angle is pi over 6, right? What's my angle of rotation? So my angle of rotation would have to be, okay, pi plus the alpha, right? Pi over 6. And so that would be 7 pi over 6, because this one's 6 pi over 6. Okay, and now we have it. Okay, and we would use the positive radius. Okay, so this would be 4 comma 7 pi over 6. Okay, another point, because if you want to do 2 of them, okay, another point, we could do the exact opposite of this, right? With a negative radius, right? So we could also do negative 4 comma, and then the exact opposite of this would be angle pi over 4, okay? Because you have vertical angles. This terminal side, if you draw the straight line, right? And here's the x-axis, these are straight lines, right? So you have vertical angles here, okay, for math 2, all right? So negative 4 comma, okay, pi over 4. So pi over 4, we'd go in this direction, right? But because the radius is negative, we're going to go in the exact opposite direction, okay? You could also do the same radius of 4 and go around more than once, right? Okay, so if you go around more than once, okay, a full rotation back around would be 12 pi over 6. So this would be 19 pi over 6. So those are 3 examples, right? Okay. We could also do, if this is pi over 6, we could rotate this way, right? So we could also do 4 comma, and if we rotate this way with a negative angle, right? If this is pi over 6, this angle right here would be negative 5 pi over 6. Okay, so all of these describes that point right there. And pay attention to something here, okay? Notice, okay, if the rectangular coordinates are kind of not clean, right? Look what happens to the polar coordinates. They're kind of clean, right? And if the polar coordinates are kind of ugly, all right, they're not nice numbers, then the rectangular ones a lot of times are nice. So sometimes it's some functions are better written in polar form than Cartesian form, okay? All right? Okay, last problem here. Okay, so this one we want to go left one and up one, right? So that would be this point right here. Okay, so that's the point -1, comma 1, right? And I'm going to draw a little line to that. I'm going to draw in my right triangle. So this is going to be my R. And this side right here would be 1, and this side right here would be -1. So I know that -1 squared plus 1 squared is equal to R squared. That'd be 1 plus 1, right? So R squared would equal 2. So R would equal plus or minus the square root of 2. And that makes sense with the side links, right? Okay. So you could, okay, so here's a perfect example of, you probably don't have to use, tan inverse. You could just look at this and tell me the angle of rotation probably, okay? Because you can get the reference angle from this, okay? I'm going to do it as if we have, oops, not angle theta. We're going to do alpha. Okay, so this right here is my angle theta, but I'm going to use tan inverse to get alpha, right? And so alpha is equal to tan inverse of 1 over 1. And that would give you an angle of pi over 4. Okay, so that's not our angle of rotation though, right? Our angle of rotation would be pi minus pi over 4, which would equal 3 pi over 4. Okay, and if you knew that angle without doing all this work, that's fine. Okay, that's fine. Okay, so our R would be the square root of 2, and our angle of rotation would be 3 pi over 4. Okay, another way would be we could do a negative pi over 4, right? Okay, so negative pi over 4. But that's the angle in the opposite direction, right? So we would need this to be negative square root of 2 to get you to go in the opposite direction, okay? Square root of 2 and add 8 pi over 4, and that would be 11 pi over 4. That would just be going around more than once, okay? We could do radius of square root of 2 and rotate with a negative angle. So this would be negative 4 pi over 4. So we need to go negative 5 pi over 4. And so there's just a lot of ways to write the coordinates, right? That's the point of this, is there's a lot of ways to write the coordinates. Okay? All right, guys. So that's polar coordinates in the kind of a and the conversion between rectangular and polar to rectangular. Okay. And then the next thing we're going to do is we're going to think about what do some of these graphs look like. Okay. And that's what's next. Okay, so let me slide this down just a little bit. Okay, so we want to graph all the points that satisfy the given polar equation, okay? So we're getting into some equations here, okay? So R equals 2. What would R equal 2 mean? It means all the points where the radius is 2. Doesn't matter what the angle is, okay? So if the angle doesn't matter and the radius is 2, well, that'd be a point right there, right? Well, right here would be a point. Well, also right here would be a point, right? That would be 2 comma pi. This would be 2 comma 0. This would be 2 comma pi over 2. This would be 2 comma 3 pi over 2, right? All of these points, right? And so if you have a radius of 2, what that means is you have a circle with radius 2. That's all it is, okay? So it's just this circle right here. Okay, so in polar coordinates, the equation R equals 2 is kind of equivalent to like having a horizontal or a vertical line, okay? And that's what the graph would look like. Kind of crazy, okay? Over here, R equals -2. Okay, so R equals -2. So the radius has to be negative. Like, how do you draw negative, right? Or negative radius? Well, negative radius just means the opposite direction of the angle, right? So let's say 0, angle 0, and the radius is -2. So let's say like we want in polar form or polar coordinates, we want to do -2, 0. Well, that'd be angle 0, and we wouldn't go this direction, right? We'd go in the opposite direction, so that'd be this point. Okay, so how about 3 pi over 2 and then have a radius of -2? So 3 pi over 2 down here, right? But if we have a negative radius of 2, that would put us up here. Well, what if we rotate pi with a radius of -2? Well, we rotate pi, right? And then we want to go -2. So instead of going this direction, we're going to go in the opposite direction, right? Guess what? It's the same line, right? It's going to be this circle with radius 2, okay? Because it doesn't matter what the angle is. The radius is always -2, which just means whatever angle you put in, you're going to go in the opposite direction too, right? Doesn't matter what the angle is. You're going to go in the opposite direction of whatever angle you put in, okay? So that's not a very good circle, but you get the idea, okay? So both of these describe the same equation, right? Okay, so the next is, I want to look at this next one, okay? So this time there's no radius, it's just theta equals pi over 6, right? So theta is equal to pi over 6. Well, pi over 6 would be right here, right? So it doesn't matter what the radius is. So what it could be is we could have a radius of 1. We could have a radius of 2. We could have a radius of 3. Okay. All right. We could have a radius of -1. Well, if we have a radius of -1, we're going to go in the opposite direction of pi over 6, right? So that would actually put me over here. We could have a radius of -2. Okay. Pi over, -2 comma pi over 6. So pi over 6, but we have to go in the opposite direction, right? So that would put me right here. We could have a radius of -3. That would put me right here. So wouldn't it be on the opposite side of this angle pi over 6, right? Guess what you're forming here? You're forming a straight line. And so the graph of a constant angle is just going to be a straight line. That's kind of trippy. Okay. And now that's what the graph of theta is equal to pi over 6 looks like. Okay. Because the angle for any point on this line, the angle is going to be pi over 6. These would all be with positive radiuses, and these would all have a negative radius. Okay? All right, let's go to the next part. Okay, so for this next example, we want to find an appropriate graphing window and produce a graph of the polar curve on graphing calculators or on Desmos, okay? So if you look at this, okay, the period has changed on this, right? And that's going to cause some things to happen, all right? But your radius, your radius is going to get is 1, okay? Because the sine function only goes as high as 1 and -1. So your radiuses are all going to be between -1 and 1, okay? Which means when you set your window, it's based on your x min and x max, okay? So the biggest that radius can get is 1, all right? So what we're going to do for our x's, okay, we're going to set a window that's between -1 and 1, okay? And because the radius is also between -1 and 1, the y's need to be the same thing. So we need to do a square window to really see an accurate graph of this, okay? So our y is going to be also -1 to 1, okay? All right. I'm going to go through all of these first, and then we're going to go and look at the graphing calculator one by one, okay? All right. So, okay, so this number right here, cosine is alternating between 1 and -1, right? So that means that the biggest this is going to be is 2, and the smallest is going to be is -2, okay? So when it's when this, I should say, re-say that, okay? This is between 1 and -1, right? So when this is 1, that's when the radius is going to be the smallest, because it's going to be 1 minus 2, which is -1, okay? And then the biggest the radius is going to get is when this cosine value is -1, right? And when this is -1, that would make this +2, right? Okay, so 1 plus 2 is 3. All right, so the smallest it's going to get is -1, and the biggest it's going to get is 3. So I would do a window setting like from -3 to 3. Okay, so for the x's, I'm going to set -3 to 3, and the y's are also going to be -3 to 3. okay? We can do our X scale or our Y scale, anything we want to, okay? And we're gonna make these all go around once and see what happens, okay? So all the angles between 0 and 2 pi, we're gonna put into theta, okay? So 4 sine theta, okay? So the biggest this is gonna get is 4, and the smallest it's gonna get is -4. So I would set my window at -4 to 4. And for the Y, I would also do -4 to 4. Okay, so now I'm going to go to the graphing calculator and take a look at this. And one thing I want to say about this one, okay? Remember, the period for sine is 2 pi, okay? So what you're going to see is, well, I'm going to explain how you're going to see it, okay? But it'd be 1/6 times 2 pi, okay? That would be the period of this function. So you're going to see, and it's going to start repeating after every 2 pi over 6, which is pi over 3. It's going to repeat every pi over 3 as we go around, okay? And so I'm going to talk about that in just a minute when we go to look at this, okay? And why it's going to look the way it does, okay? All right, so I'm going to go to the graphing calculator and show you on that. Okay, so from our home screen, we want to press mode, and then what we want to select is polar here, okay? So I'm going to come down and select polar. Okay, now we've used all of these, huh? Okay, and y equals, and we're going to type in sine of 6 theta. And notice it says r, right? Because the radius is determined upon the angle that we put in, okay? So 6 theta. We got to make sure we're in radians up here. Okay, so our window. Okay, so we're gonna start creating angles at 0. This is, well, let's type in 2 pi because yours might be different. So 2 pi. Okay, and then I'm gonna go down. So 6.28, right? That's pi. And for theta step, we're gonna start at 0. And what are the steps that we're gonna go into? What theta values are gonna put in? And this is tell you what you're gonna go up by each time. So let's put in 0.01. I think that's the best. Okay, and then what we said earlier was x min is -1, and x max is 1, and x scale 0.5 is good, y min -1, y max 1, y scale 0.5. Okay, and so I'm gonna change this theta max to show you what's going on. We're just gonna graph the whole thing at once, okay? And so let's go ahead and press graph. Boy, that goes really fast. Okay. So like you can't see, right? It's like a big old flower, right? And it has 6 petals. Okay, I'll explain why it has not 6. It has 12 petals. Okay, and it's kind of distorted a little bit because the horizontal distance is from -1 to 1. So but this window is smaller, right? So you can fix that by going to zoom, and go to zoom square. So this will square up the window, and then it looks a little more even, right? Okay. All right. So what that does is every unit on the x-axis and the y-axis is the same length. So right here is 0.5, and this is 0.5, and those are the same lengths. Okay. All right. So why does it have 6 petals? Okay. So the period was pi over 3. Okay. So if I go to my window and I'm going to change my theta max to pi over 3, okay. So I have to pi divided by 3. Okay. This is one period of it, okay, that we're going to graph now. That's it. Okay. Now, from 0 to pi over 6, okay, sine of 6 theta from 0 to pi over 6, okay, because we're multiplying by 6, that's going to be sine values for 0 to pi, and they're all positive. So from 0 to pi over 6, we're going to get all positive radiuses, and that is this one right here. Okay, so from 0 to pi over 6, we're going to get a positive radius. So it starts here and comes up like this, and then comes around, okay? And then what happens is after pi over 6, okay, now what happens is, because you're multiplying by 6, okay, what happens is you're going to get negative radiuses from pi over 6 to pi over 3. You're going to get all negative radiuses. So that's going to give this piece, okay? And so what happens is it does this all the way to 2 pi. So from 0 to pi over 3, you're going to get 2 leaves, okay? So that would mean from 0 to pi, you are going to have, okay, a total of 6 leaves, okay? Because you're going to get one of these and one of these for every pi over 3. So you're going to get 3 up here and you're going to get 3 down here, okay? So I'm going to do that. I'm going to go from 0 to pi, 0 to pi, and let's take a look and see what happens. So second pi. Okay, now we're going to graph, and we should see 6 of them. Okay, and it didn't quite finish, right? Okay, so 1, 2, 3, and then 4, 5, 6, right? Why? Because pi over 3, from 0 to pi over 3, you're going to get 2 leaves. From pi over 3 to 2 pi over 3, you're going to get 2 more leaves. From 2 pi over 3 to 3 pi over 3, right, or pi, you're going to get 2 more leaves, right? Okay, so what happens is you are going to, as we go around to 2 pi, nothing ever overlaps. And what happens is you wind up with 6 more leaves if you go all the way to 2 pi. So that's why there's going to be 12 petals, not leaves, petals, okay, for this. It's called a rose curve, okay, for this rose curve, okay. So let's go window, and let's go all the way to 2. Well, let's go to 4 pi over 3. I'm just trying to give you insight that I have, and I've had to work all through this, okay, and think about like, okay, why is it doing that? Okay, so 0 to pi over 3, we have 2 petals, right? From pi over 3 to 2 pi over 3, we have 2 more petals. From 2 pi over 3 to pi, we have 2 more petals. And so we're going from all the way to 4 pi over 3, right, which is another pi over 3. Now we should have 8 petals, okay? And yeah, you know what? I'm going to make this slow down by doing, I'm going to go 0.01. Don't do this on your calculator because it would take too long, okay? But I think it'll slow it down for us. So there we go. Actually, you know what? I thought of another way to do this, to explain this to you, okay? Let's go to 2 pi. Because I can pause it. Okay. From here to here was pi over 6. Okay, now we're looking, I'm going to press on again because it'll start graphing. Okay, when we stopped right here, it was pi over 3. So we got this petal for 0 to pi over 6, and we got this petal from pi over 6 to 2 pi over 6. So every pi over 6, okay, so this is another way to explain it. Every pi over 6, we're going to get a petal, okay? So from 0 to pi over 6, we got 1 petal, and then from pi over 6 to pi over 3, we got another petal, okay? This would be where the radiuses are positive because for sine of 6 theta, okay, the graph would be above the x-axis, which means sine is positive from 0 to pi over 6, and then it's going to be negative from pi over 6 to 2 pi over 6, which is pi over 3, okay? All right, so from 0 to pi over 6, we're gonna get 1 petal. So from 0 to pi, we're gonna get 6 petals, and from 2 pi, we're gonna get 12 petals, okay? Because there's 12 pi over 6s in 2 pi, okay? Pi over 6, another 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 pi over 6, and another pi over 6, and it stopped, right? So because from 0 to pi over 6, the radius is getting bigger and then smaller, okay? Then that's what's happening. That's why you're getting this part right here. Okay? That's why you're getting this part right here. Okay? I wish I could point to this on the board with you guys. It's a little easier than my little arrow right here. Okay, that's enough said on that one. Okay, so it produces this, it's called a rose curve. Okay, if this happened, I'm going to talk about this. We didn't do this. Okay, but if it was cosine, 6 theta. Watch what happens on this one. You again only get, well, you get what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You get 12 petals again, right? Okay. All right. So another curve that we're going to see is this one. Okay. So 1 minus 2 cosine theta. Okay, so we're going to graph this one. Let's go window. Let's go -3. So -3, 2, 3. Scale by 0.5 is fine. -3, 2, 3, and 0.5. Okay, so let's graph this one. So at pi, right? Why is this one the furthest one away? Because at pi, cosine of pi is -1, right? And when you take 1 minus 2 times -1, that's going to give you the biggest radius. So angle pi is going to give you the biggest radius. So that would be pi right here. Okay. And so it has this little loop, right? Okay, in it. And if we do zoom and then square, we see it a little bit better. And this is what it would look like if you graphed it on polar graph paper, okay? So it looks like that, okay? All right, and this is called a limachon, okay? All right, so then that's what that one looks like, okay? And what we're gonna do tomorrow is we're gonna do calculus on this, okay? So we're actually gonna find the length of this, and we're also gonna find the area, like the area of this region, you know, this region right here, and the area of this region in here, okay? Okay, and then the last one we're gonna do is y equals 4 sine theta. Okay, so clear this one out, 4 sine theta. So really this is just about analyzing it and looking at it and seeing some different graphs that are produced. Okay, for this one, our window need to be -4 to 4. So come down here, oops, too far. -4 to 4. And x scale 0.5 is fine, and then y min -4 to 4, and y scale 0.5. Okay, and graph it, and then we'll do zoom square. Okay, so here's the problem, okay? Because it's distorted in the horizontal direction, it doesn't look like the shape it really is, okay? All right, so if we do zoom square, we'll see the actual shape. And what does it look like to you guys? It's a circle, right? So 4 sine theta is the equation of a circle in polar form, okay? And also like 4 cosine theta. So what happens is if this was -4 sine theta, it'd be down here. If it was 4 cosine theta, it'd be right here, okay? If it was -4 cosine theta, it'd be over here, okay? And it would just put the circle at different spots. The center would be different places. Okay, so that's the graph of it, okay? And so the next thing we're going to do is we're going to convert these equations that are in polar form, and we're going to convert them to rectangular form, okay? And that's the next and last thing. This is usually all done in like a pre-calculus class, just so you know, okay? When I taught pre-calculus, I used to do this all the time, all right? Okay, so let's stop this and we'll go back to our paper. So what we're going to start out with is use the polar rectangular conversion formula to show that the polar graph of r equals 4 sine theta is in fact a circle, right? Okay, and a circle is x squared plus y squared equals the radius squared, okay? All right, so what we're going to show is that this is going to come out to be a circle. This is this one right here, right? Okay, and so we're going to prove that it's a circle. Okay, so one thing we know, okay, is that r. Let's start with this. R is equal to 4 sine of theta, right? And what do we know sine theta is? Well, sine theta is y over r, right? So that we can start with that, okay? So r is equal to 4 times y over r. So that would be r is equal to 4y over r. And to clear out the fraction, I can multiply both sides by r. So that would give me r squared is equal to 4y. Okay, so here we go. Okay, so what can we do with this? Well, we know, okay, Pythagorean theorem, that r squared, right? R squared is equal to x squared plus y squared. I'm going to do that in a different color here. So we know that x squared plus y squared is equal to r squared. So it's always good to get r squared because you can replace it with x squared plus y squared. Okay, so this is going to get replaced with x squared plus y squared equals 4y. Okay. All right, so how can you show that this is a circle? Well, the general equation of a circle that you should recall from Math 2, okay, and even Honors Math 3 is it's x minus h squared plus y minus k squared is equal to r squared. So if you can get into this form, the center is h comma k, and the radius of the circle is r, okay? All right, so we don't have that form, okay? So what we can do is move the 4y over, okay? And that would become x squared plus y squared minus 4y equals 0. Okay, and what we need to do is we need to complete the square. So we need to make a perfect square here, okay? So if we make a perfect square, okay, what we need here is y squared, right? And then we need to split this negative 4y equally into these two pieces, right? So this would be negative 2y and negative 2y, okay? And then if we factor across, this would be y, and this would be y, and this would be negative 2, and this would be negative 2, and negative 2 times negative 2 is positive 4, okay? So to get this 4, to make this a perfect square, we're going to need to add 4 and also remove 4, okay? So this makes x squared plus y squared minus 4y plus 4 minus 4 equals 0. And these three right here can get factored into because that's my square right here, right? It's y minus 2 times y minus 2. So this would be x squared plus y minus 2 squared minus 4 is equal to 0. Okay, so that would mean x squared plus y minus 2 squared is equal to 4. But now this 4 is 2 squared, right? Okay, so I can tell by this number right here that that's r squared, so my r would have to be 2. So I can tell this is a circle, right? And the center, we didn't move the x at all, right? So it'd be 0, and we move the y up 2, because that's what that would do. So 0 comma 2, and the radius would equal 2, because this is the radius squared right there. That 4 is the radius squared, so the radius would have to be 2. And this is a circle, and we just showed it. We just proved it, okay? All right, so we showed that that's a circle. Let's go to the next problem. I didn't say this on the last example, okay? But what I should have said is like, okay, so that equation in polar form was very simple, right? It was 4 sine theta, right? That's a circle. That's a very simple equation, right? And to write that same equation in Cartesian or rectangular coordinates, right? Or not coordinates, rectangular equation or Cartesian equation, It's a much more complicated equation, right? So that's what the beauty of this is. It takes these complex equations that are in rectangular form and makes them really simple in polar form. And that's kind of the reason we go to this sometimes, okay? All right. Okay, so we want to use analytical methods to produce or to replace the polar equation r squared sine 2 theta is equal to by an equivalent Cartesian rectangular equation, okay? So what the heck would this produce, right? Okay, we might be able to see if we can figure out what the Cartesian equation is, we might be able to recognize the Cartesian equation, okay? All right, so we're going to start off with r squared sine of 2 theta is equal to 2. Okay, sine 2 theta, that's a double angle identity in trig, right? And so this would be, we could rewrite this as r squared times 2 sine of angle theta cosine of angle theta is equal to 2. Okay, so the next thing I would do is we can swap out the sine theta with y over r and the cosine with x over r. So this becomes r squared times 2, and then sine theta is y over r, and cosine theta is x over r is equal to 2. Okay, so this would be, if we multiply this, this would be 2 r squared xy over r squared is equal to 2, right? And what happens is my r squareds cancel, right? So now I'm left with 2xy is equal to 2. Dividing both sides by 2, I get x times y is equal to 1. And so y is equal to 1 over x. Okay, so this is the reciprocal function, right? That's a parent function that we learned last year, right? Okay, now look, this is a really simple one, right? And look at it in polar. It's complex. It's more complex, all right, than it is in Cartesian. So we just showed that, okay, something that's simple in polar becomes complex in Cartesian, and then something that's complex in polar becomes simple in Cartesian. So there's a reason for both coordinate systems, okay? All right? Okay, so if we graph this, which we really can't do because it's r squared, we'd have to solve this for r, okay, to graph it, okay. All right, so this is y equals 1 over x, okay. That's what the graph would be the same, okay. All right, it would take, well, actually you could do this, okay. What you'd have to do, let me explain what you'd have to do. You have to do r squared is equal to 2 over sine of 2 theta, okay? And then you're going to square root. And when you square root this, you're going to get the absolute value of r is equal to the square root of 2 over sine of 2 theta, right? And then what you would get is r is equal to plus or minus the square root of 2 over sine of 2 theta. So you'd have to put the positive one in and the negative one in, and that would produce the same graph, okay? And just to get you to know how to put it in your graphing calculator or Desmos, okay? Actually, you might be able to put this one directly into Desmos and graph it. Okay, guys, that's it. Let me grab my assignment sheet and we'll talk about what. So for this polar functions day 1, what I want you to do is page 564, 1 through 37 odd. And I've given you some graph paper to go along with this, okay, to do this, okay? And then tomorrow we're going to do calculus on this stuff, okay? Today wasn't calculus at all, okay? It was just all like algebra, pre-calculus type stuff, okay? And I put this date just to follow along. I'm a couple days off because I had some meetings I had to attend and stuff, okay? So tomorrow, last day, okay? It's just this right here, 39 through 59 odd, okay? All right, guys, you guys have a wonderful day. Take care. Bye.